Hello friends, and welcome of you to this new course. In this course we will apply the Spring Security on a Spring Boot web application. In my previous course, building a web application using Spring Boot and Timeleaf, I told you that we will make a separate course for the Spring Security because it's a big issue and security needs to be handled carefully. We will apply the Spring Security on the same web application that we have developed in that course, building a web application using Spring Boot and Timeleaf, which was a very simple web application, just a few pages, some social links, a login form, a registration, and a reset the password pages. This is the simple web application that we have developed, and this is the entire code of it. For those of you who wish to get that code, they can go back to my previous course, the building a web application using Spring Boot and Timeleaf. Okay, so now let's dive in. The first thing we need to do when we focus on the security is that to focus on the database. This is the first thing that we have to handle carefully, because in the database we will create the roles, the authentications, and we will link the tables, and it's the fundamental thing to do first thing when we care for the security of a web application. I have developed a database which was the same ones of the previous course, except that this time it's been done in appropriate way, handling the roles and the authentications for the users, and we will apply it all in the database. So the same database, we create a database by this name, whatever name you wish. We apply the UTF and the collat. Then you can use few codes here to show the tables if there's any tables, but it's better to delete all these tables. Whatever tables you wish to do, usually there are roles table, authority table, the users table, and the user role and the user authority table. Now let me show you here on the MySQL workbench. This is the same code of creating the database, and this is the reverse engineering of it. Now these are the main tables: the users, the authority, and the role. Now each user could have multiple authorities, and one authority could be applied to multiple users. So this is a one-to-one or many-to-many relationship between these two tables. So that's why we need a bridge table. The same thing goes with the users and the roles. One user could have multiple roles, for instance admin or user or DB manager, and one role could be applied to multiple users. So it's a many-to-many relationship between these two tables. That's why we need a bridge table. Now you might wonder, what is the authority and what is the role? Now the authority, basically the name of it is an arbitrary name, any name you could assign to any authority. Now this authority will give the user the privilege, the permission to do something when he access to your web application. Some work, some job, this authority will entitle the user to do it when he or she access to your web application. This is the authority. Now the roles, on the other hand, the roles are like a container, a combination of authorities together. We set them in what we call a role. So the role admin could contain one or two or three authorities. The user role can contain multiple authorities, and the same thing with DB manager or whatever roles you wish to create with for your web application. And the same thing as we said with the authorities, you can create whichever authority you wish to your web application. Now in my case I have created three, as we see here, three tables: authority, users, and role. In your case you could create any number of tables depending on your requirement, but the main subject, the core subject of this is that you need to create the authority table and the role table, and then you link them to the user so you can assign the authority and the roles to the user. This is the main understanding. Other than that, you could create any number of tables that is suitable for your web application requirements. Now to create these tables and authorities, it's in my SQL database. You could go to create the role table. It has two things: the role ID and the role name. It's preferable to make it as a unique. For the role name, you should make it unique, and then some description about this role. And the primary key in this case is the role ID. The engine, you could select whichever engine you wish for your table. In my case, I'm the InnoDB. Then you create and insert some roles. The roles names and number depends on your requirement. For instance, in my case, I've created 4 roles, which is super, admin, user, and DB manager, and you can insert them in the role table. The second thing is that you need to create the authority table. The same thing, you can create an ID, which is auto-incremented also, and the authority name also unique. It should be a unique, the authority name, and some description about the authority, what this authority do. And then you make the primary key as the authority ID. And again, the engine is InnoDB. Create an arbitrary name for these authorities, assign them, and save them, insert them, persist them in the authority table. You can create any number of authorities based on your requirements for your web application. Now it comes to the users table. Now the users table columns depends on your requirement with your web application. For instance, in this simple web application that we have created in the previous course, you could see when a new user wish to register to your application, I selected few fields such as the user ID, the email, the password, first name, last name, and recovery email. Now this field, I have inserted them into the table, but this is for my web application that I have designed. In your case, you could select any number and any types of fields that you wish to add to your web application. Moreover, you need to set also the columns for the user role, user authority, and enabled, and some other roles for the token. This is the token that we will use when we wish to reset the password of the user, and the status, which is whether this user is active or not active. So these are the basic fields that I have used. In your case, you could select whichever fields suitable for your requirement. And there are 2 columns here, as you can see, the user role and the user authority. We need also to add them, to assign them to each user. We need to assign a role and authority, and we need to make whether this user is enabled, active or not, and then finally the token DB for when this user wish to reset his or her password. Now the primary key in this case is the user ID, and it's auto-incremented also, and obviously the user ID should be unique. Now since this is a many-to-many relationship between these databases, between these tables, as we have showed in here. These are many-to-many. One authority can be applied to many users, and one user can have multiple authorities, and the same with the roles. So we need to create the bridge table, which is this bridge table for the authority and the users, and this table for the roles and the users. And this can be done with these two tables. So we get the user ID and the role ID as the primary keys, and we create the foreign key for this case, and then we assign the foreign keys for both the user ID referencing the users table and the role ID referencing the role table. And don't forget to set whether it's for the foreign key, what is the restrictions on it, and how to handle it when it's been updated, the user data is updated. In my case, I am selecting on delete, restrict, on update, cascade. The same thing we can do with the table of the user authority. The user ID, authority ID as primary keys, and the foreign key we create the authority ID, and the foreign key is referencing two tables. Now this is the general design of the database. You need to alter this design to suit your requirements, whether you change the fields, the names, the number of roles, the number of authorities. This all can done based on your requirements, but this is a general design how you can do this. Okay, now the second thing is that we need to set the properties of the database and the properties also of the database pool. This can be done in the application. Now we go to the application, and under the directory of the resources there is a file by the name application properties. We open this file and we start to set the properties for the database and the database pool. So first thing, we need to select the driver and which database we will use. In this case, either you can use the MySQL or you can use the PostgreSQL database. You have to select whichever one, the name of the user and the password. Now once you have selected which database you will go through, you need to add this server time zone UTC. This will save you an exception that will happen when you upload your production web application to the remote server. The production version of your web application, when you upload it to the remote server, if you don't add this code, you will get an exception about time zone conflicts. So now you set it as a universal time zone, which will save you of getting that exception. Now once you have selected, let's say you selected the MySQL database, then you need to select the dialect of it, which is MySQL 5 dialect. If you choose to select work with the PostgreSQL database, then you need to select the dialect of PostgreSQL dialect. Now the strategy naming, the naming strategy of the annotations, it's from experience I realized that using this strategy will save you some exceptions that will happen when reading the annotations of the models. For instance, this is the model of the model class of when you do the annotations. Now there should be a strategy to read these annotations. Now selecting a physical naming strategy will save you an exception that will happen if you so choose to select another strategy. Another thing, if you have columns with blob type, binary large object type, any column in your database, if it's of type binary large object, it's better to set this property to true, and this will save you one exception at the production level of your web applications. And then you can, if you wish so to choose, Spring GPShow SQL, the DDL update should be update instead of create. Now we come to the properties of the pool Now you are free to use whichever pool suitable for your requirement. In my case, I'm selecting the Hickory pool, and these are the settings of the Hickory pool. You can change these properties and the values of these properties based on your web application requirements, but it's very essential and it's very important that you choose a pool, a database pool, because the pool will enhance the performance of your database, and accordingly the connection between your users and with your application will be seemingly less efforts and more fast. Now once you have done these properties, that means your database and your properties have been set up based on your preferences, and this will be all for this video. From next video we'll start doing the security work. Thank you very much.